So this is our section on lipids. So you can see here on our first slide that lipids are fats, fats and oils. So on this we have butter, which is fat. Anything fried, you're frying in oil, so that would be a lipid as well. Bacon, we also have protein in there with the meat, but the fat on bacon would also be considered a lipid. Over here, ice cream, we have your disaccharides with your lactose in there, but there's also a lot of fat in ice cream too, so that's considered a lipid. And the icing here on the cake, probably buttercream, good choice, but still a lipid. So lipids are composed of carbon, hydrogen, and oxygen, just like our carbs are, except the ratio of hydrogen to oxygen in lipids is greater than 2 to 1, whereas in carbs it was exactly 2 to 1. They're insoluble in water, which means they're hydrophobic. They are not classified by their structure, they're just grouped, so there's no mono, di, or polylipids. What they do for you is they're going to give you structure. They make up your cell membranes. Cell membranes are made up of a phospholipid bilayer. So lipids are going to make up every single one of your cells, and you have trillions of them. Finally, they do function in providing energy, just like carbs do, except they actually provide more energy than carbs. You could eat a pound of carbs and a pound of lipids, and there's more energy in those lipids. But they are harder for your body to break down than carbs, so your body uses them last. You need to burn through all of your carbohydrates before your body will actually start to pull from your fat. So the three groups of lipids that we're looking at in this video are triglycerides, which include phospholipids as well, so both of those things are in one category, waxes, and steroids. So triglycerides are first. Triglycerides are made of 1 molecule of glycerol and 3 molecules of fatty acids. And they're all going to be bonded together by, you guessed it, dehydration synthesis and broken down by hydrolysis. So here we have our 4 parts, glycerol, 1, 2, 3 fatty acids. We take the water out of these chemical structures, show it on the right here as a product. Because we removed that water, you can see that the bonds are forming here between the glycerol and the fatty acids. If your body needs to break down a triglyceride, we will add the water in, which will break these bonds apart, which create your 4 monomers here, the 3 fatty acids and the glycerol. Hydrolysis to break down, hydro water, lysis to split, dehydration synthesis to build, dehydrate, remove water, synthesis to make. The glycerol is an alcohol, and it is the same in every single triglyceride. Fatty acids are long carbon chains, and they vary in structure. Therefore, there's many different types of fatty acids, and therefore different types of triglycerides. Phospholipids are very similar to triglycerides. They have a glycerol, and they still have 3 fatty acids, but the last fatty acid is modified, so it has some phosphorus in there, different than the other 2 fatty acids. We're going to put all those monomers together using dehydration synthesis, remove the water to make the bonds, and we would break that down by hydrolysis, adding water to break those molecules apart into their monomers. Phospholipids are both hydrophilic and hydrophobic, so that goes against what we said about lipids being all hydrophobic. The modified fatty acid here likes water, whereas the glycerol and the 2 regular fatty acids hate water. So the overall structure is represented here. We have the blue hydrophilic head there. That's the modified fatty acid. Then the hydrophobic tails here at the bottom, they hate water, and that would be the glycerol and the 2 other fatty acids. Our cell membranes are made up of phospholipid bilayers, so you're going to have 2 layers of phospholipids, one on the top here, one on the bottom. You'll notice that the heads are situated to outside and the tails are in the inside. That's because this area out here, say the environment of the cell, is going to contain water, and the inside of the cell does contain water as well. So these tails here are getting away from the water. They don't want anything to do with it. Molecules will move from in to out of the cell or out to in. The next category of lipids are your waxes. These are the waxes that you're thinking of when you think of waxes. They are made up of one molecule other than one alcohol other than glycerol and 3 fatty acids. If this molecule was glycerol, it would be a triglyceride. So it's got to be some other alcohol. Put these molecules together in order to build the wax. That would be dehydration synthesis. Take the water out to build our bonds. Hydrolysis, going the other way, add the water in to break the bonds. Hydro, water, lysis, break. Waxes are solid at room temperature. They are water repellent and keep out microorganisms. And examples of this would be earwax. Earwax exists in your ear in order to keep out those microorganisms, prevent them from getting into your ear canal, and basically causing infections. Waxy coating on fruits, leaves, vegetables help with being water repellent, and same thing with the waxy coating on many insects. Steroids are our last category of lipids. They are different in structure from all the other lipids. We're not going to get into great details about hydrolysis and dehydration synthesis with steroids because there's a lot going on here. But they are made up of 4 carbon rings. I won't sing to you this time, but 4 carbon rings all attached to each other. They do have other atoms coming off of them, but the carbon rings are very standard. Examples of steroids would be cholesterol. Cholesterol will coat your blood vessels and can cause your blood pressure to increase, could put you at a risk of a heart attack or stroke. But there is also good cholesterol that will help you aid in digestion. Even if you don't eat any foods with cholesterol in them, your body will still have cholesterol because your body makes it because it helps you with digestion. Hormones like testosterone and estrogen are considered to be steroids, as well as vitamins such as vitamin D. Plant toxins like poison ivy are considered to be steroids, as well as any animal toxins like scorpion venom, black widow venom, snake venom in general. Then obviously you think of the steroids, like drug steroids, either the anabolic ones, which are illegal for you to take to juice up for sports, or even there's steroids that a doctor would prescribe to you that would help you if you had some sort of infection or virus. Which brings us to proteins.